Ever wonder how electricity gets brought into your house? Well, this week we're exploring the operations of the power grid. So behind me is a backup generator powered by natural gas that the school uses. This generator uses an internal combustion engine that burns the natural gas and uses a mechanical connection to actually spin the motor to create the electricity. A generator is a very important first step in any grid. Most generators use heat, and that creates steam that turns the turbine, so it's not a direct connection like behind us. So a hydroelectric plant and wind turbines also use a physical connection to turn the electric motor rather than relying on heating water and using steam. The last type of power generation is photovoltaic, also known as solar panels.
Hello, we are now standing in front of some distribution lines. So these are medium to high voltage power lines, generally three-phase, as can be seen by the three cables, although sometimes it is single phase if it's a small side street or whatever. And this is the last step before the electricity goes into a transformer and a step down to the voltage that people actually use in a home or business. So you'll see these running through neighborhoods and things like that. Also, these are sometimes buried underground, especially in European countries, although in America, in more rural areas, they tend to be above ground on poles. And they tend to be around 10,000 volts, although it can definitely vary depending on the use. And these are fed by a town's substation or whatever from the sub-transmission or transmission lines after going through a transformer to be stepped down, of which there is one behind me. Essentially, the role of a transformer in the grid is to either step up or step down the voltage of the electricity being transmitted. There are a couple of reasons for this. The first reason is that a higher voltage can tolerate more of a voltage drop before it becomes a problem, and also a lower current has to be pushed through the wires, allowing for smaller diameter conductors. This saves money and makes the system more efficient. It's also the reason that alternating current has to be used, as direct current does not work with a transformer. Right up here, some important pieces of hardware for the grid would be right there on that pole that's further back, right at the top, there are things called cutouts, and they're essentially fuses so that if there's an overload on the line, they will cut out and stop the flow of electricity to prevent damage. This is often, if you hear a bang and then the power goes out, people often think it's a transformer, but that's often wrong. It's often a cutout because they make quite a loud sound. There may also be a form of power factor correction right up at the top of that pole. Hello, we are now sitting in front of a electrical panel. In this case, it is in the tech booth of the school. And the way this works is essentially there are breakers that come in from the feeders, and those are essentially, if it was just in a house, that would be the lines coming off the transformer, come into your house, come down through the weatherhead, and then come to your panel. In this case, this is a sub-panel, so they're being fed from a different main panel, probably in the basement somewhere. In this case, the breakers go off into smaller cables. In this case, they're 20 amps each, into separate outlets.
And now, when you plug it in, it turns on. And now you know how the grid connects to your outlets at home.